Hey guys, in this section, 9.04, we're going to talk about the quadratic formula. Now, here's the thing about the quadratic formula. It's simple, right? It's just a formula. We just plug numbers in and we're going to get our answer, and it's going to be pretty simple. But it doesn't necessarily mean it's too easy. If you know how to use a formula and you know how to plug numbers in a formula, and especially know how to evaluate a formula, then you'll be fine. Okay? But just keep in mind you have to keep your focus when you go through this formula, okay? Don't lose focus in the middle of it, because if you do, that's where people end up making mistakes. Now, a quadratic formula is used to find the zeros of any quadratic, which are the x-intercepts, okay? Now, the quadratic formula can solve any quadratic. It can find the x-intercepts, the zeros of any quadratic, but that doesn't necessarily mean you should always use it. You know, sometimes because it is such a big formula, it is a little bit more of a pain to use. So it would take more time to go through the quadratic formula than to do other methods that we've learned in the past. Like, for example, factoring. Sometimes if you're good at factoring, you can solve a quadratic in just a matter of a couple seconds if you're good at factoring. And then there are other cases as well. You can just straight up solve the quadratic without having to factor, without having to use the quadratic formula. And those methods can be faster. But the quadratic formula will work on every single quadratic you see. And that's why we see a lot of them, you know, when you kind of try to Google the answers, they'll use the quadratic formula. Now, we're aware of that, so just keep in mind, we still don't accept anything that's been copied off, other internet sources. So you guys should be fine if you want to try and learn it. Just quit trying to take shortcuts, is what I'm trying to say. Okay, so let's get into this. Okay, the quadratic formula. Just kind of to go backwards in the process, you know, we've talked about completing the square in the last week's video. Now to find the quadratic formula, you actually go through a process of completing the square, but we're not going to get into that right now. I just really want to show you how to use the quadratic formula and work out several examples with that quadratic formula. Now they have a video here that shows you, so if you want to watch that one, you can. But here's the formula. You can see it on the blue side there. I'm going to explain everything about that formula once we see an example to work out. Okay. Again, there's another video. There's a bunch of videos. There's all these videos. I guess. Let me go down here though, the ones that don't have a video, and I'll work out some of those just so you get the idea. Now, obviously, it shows you all the steps. It shows you several steps because it tries to break it down piece by piece. All right, so I'll explain what all these steps are when I go to work out this problem. So here's my problem. I have 0 equals x squared plus 4x plus 1. Let me go to my whiteboard. Okay, now I've written the quadratic formula here. Now, actually, I kind of forgot a piece because it is x equals, oops, I guess let's go back to the red. X equals this. And it's x equals because remember the quadratic formula is solving for the x-intercepts, okay? The x-axis zeros. But there's your formula. And if it helps, I also wrote the formula kind of color-coded. You know, where the B's are blue, the A's are green, and the C, there's only one C in the formula. The C is black. Everything else I left as red. Okay, again, this is still x equals because we're looking for the x-intercepts with this formula. So how does this formula work? Well, you need to take a quadratic. Now, a quadratic will be written as A. Let's actually use the colors to match it here. A x squared plus b x plus c. So the a, the b, the c are the coefficients or those numbers in a quadratic. So in our example that we have 0 equals x squared plus 4x plus 1. So we have just simply x squared plus 4x plus 1. Now you'll notice there was no number in front of the x squared, but we've talked about that in the past. That means the number is not 0, the number is 1. So think of that a value being a 1x squared. Okay. Now this is set up equal to 0. It says 0 equals because essentially this is functioning as the y value. Y equals all this, and if y is 0, think about this on a graph. On your y-axis, the 0 part of the y-axis is the x-intercept. So you're looking for the points on the x-intercept when it's set up equal to 0. So that's not the x value being 0, that's actually the y value being 0. The formula is where the x value is equal to 0. So what we want to do right off the bat is we want to establish what the a, b, the c are, of course, so that we can plug it into our formula. Now I've already done that because I've color-coded it, so a is 1, b is 4, and c is also 1. And now I'm simply going to try and plug that into my formula. So my formula, we have x equals negative, and now the b value was 4. And it's a very interesting part of the formula. It's got the plus minus here. We'll talk about that more once we've evaluated more of the problem, but there is a plus and a minus there. Because you're going to add one time and subtract another time. So square root of b squared, so we're going to have 4 squared. Minus 4. 4 is part of the formula. A is 1, and the c value is 1. So we've plugged that in. Don't forget, a lot of times people forget the over 2a part. So don't forget the over 2a part. That's also very important. All right, so there's our formula, everything plugged in. Again, you can see the formula up there. I've color-coded everything to match. So plugged in the b value, which is 4, the a value, which is 1, and the c value, which is 1. And now the rest of it is just evaluating. So focus your attention on the inside of the radical sign first. So the first thing I'm looking at is really 4 squared. Let's evaluate that. If it's okay with you, I'm going to skip the color coding for now just to save a little bit of time. But the formula would be negative 4 plus minus the square root. Now let's evaluate. So 4 squared. I'm evaluating this right here. This is where I want to start. I want to do this part first. So 4 squared is 16. And then I'm going to do this part at the same time, but I'll do it right after. So second, right? So we have minus 4 times 1 times 1. So 4 times 1 times 1 is 4. So this is still just going to be minus 4. So I'm simplifying those things right there, one at a time. Okay. Divided by, and we could do this third. Kind of really all do this in the same step. 2 times 1, which is 2. So I've simplified 3 pieces here, right? The 4 squared to 16, the 4 times 1 to 4, and the 2. A lot of times the easiest part to get mixed up here is this minus sign, because sometimes if any of these numbers that we're multiplying by are negative, then that minus sign will turn into a positive because a negative times a negative makes a positive. So just be very careful and try to focus on that negative a lot, because if you change that to a plus, or if you forget to leave it as a minus, or whatever the case is, if you get the sign wrong, the rest of the problem is going to be wrong. But from here on out, again, we're going to have a simple process. So we have x equals, I'm going to simplify this part. So 16 minus 4 is what I have inside the radical. 16 minus 4 is 12. So it's going to be negative 4 plus minus the square root of 12 divided by 2. So the next thing I'm going to do is just simply calculate the square root of 12. Now that's going to be a decimal for us. It's not a perfect square. In Algebra 2, you guys are going to be learning how to simplify that radical. But for our sake, we'll just use decimals. So if you take a calculator and you type in, let's see, square root of 12, we get 3.46. So it's rounded to that, say. Negative 4, of course, still there, plus minus. Now there's no square root because we're doing the square root as part of this calculation. We're taking the square root. So it's not going to be a square root anymore. It's just going to be a regular 3.46. Okay? All divided by 2 again. Now here's the part where we get to the plus and minus. So on top, the plus and minus, we're going to do -4 plus the 3.46, and then we're going to do a second time where we do -4 minus the 3.46. So essentially, we're going to break this into two sections, one with the plus sign, one with the minus sign. So let's do the plus sign up here, -4 plus 3.46 divided by 2, and then the one with the minus sign, -4 minus 3.46 divided by 2. So again, we just take our calculator and we'll work it out. So let's subtract this first. So -4 plus 3.46 would be -0.54 divided by 2. And if I go ahead and just divide by 2 there, I get -0.27. So that's one answer. Now let's do the bottom side with the minus sign. So -4 minus 3.46 is -7.46 divided by 2 still, because it's still over 2. So let's go ahead and divide by 2, and we get -3.73. And so there are our final answers. So it's just a simple formula, but you can see how it can be kind of a long process. I don't want to do too many steps at once, You see at the first part of the problem, I did 3 steps at the same time. But you don't want to try to do too much at once because that's how you end up making mistakes. So just take it a little bit at a time, and then you'll finally get your answer, right? All right, let's look at another one. All right. So example 2. Let's try it again with this one, right? So x squared minus 3x minus 4. So we have x squared okay. Minus 3x minus 4. Okay. Now I still kind of color coded this. Again, you don't see the number in front of x squared, so we remember that number being a 1. But you see, because it has minus signs, I went ahead and made those minus signs the color with the b and the c. So I made the minus sign blue because it is part of the b term, because that's a -3. That's our b value. It's not just a regular 3. It is a -3. And I made the negative for the 4 also black because the negative is part of that c value. So remember, it is a x squared plus bx plus c. But if those plus signs become minus signs, then that minus sign is a part of that value. That negative becomes a part of that value. So when we plug in our formula, we're plugging in negative numbers here. Something to keep in mind. So let's look at our formula, right? Let me write the whole formula down again. So the formula was x equals negative b plus minus, let's go back. Keep it color-coded, plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So if we plug all the values in, here's what it would look like. X equals negative. Now the b value is negative, so I'm plugging in another negative, right? You've got the negative that's part of the formula, and then you've got the negative that's a part of the b. So we end up with a double negative there. And we will simplify that, but let me just write out the formula first. So plus minus the square root of b squared. So b, remember, is -3, so we're squaring -3. -3 squared minus 4 times a, which again is 1, times c, which is -4. All divided by 2 times a, which is 1. All right, so we have a lot of negatives here. So we tend to make mistakes when we see negatives, so let's be careful. But we're going to do the same thing that we started last time, right? First thing we're going to do is start simplifying inside the radical sign. So let's do this first, same as last part, right? So I have -3 squared. Now, what's important to remember is don't just take your calculator. Here, let me show you on my calculator so you get a better understanding. It might take a second to load, and I apologize for that. If you want to skip like 5 or 10 seconds ahead, I would understand. Okay. Oh, I didn't want to click on that. All right. If you just type your calculator -3 and squared, right? This is going to register in the calculator wrong, because what it's doing essentially is it's doing the 3 squared. It's doing order of operations. It's doing 3 squared, which is exponent first, and then multiplying it by a -1. So essentially, what the calculator is going to give us a wrong answer of -9 here. But what the calculator is thinking it's doing is it's thinking -1, and then it's doing the 3 squared. That's what the calculator is thinking when you type it in the way I typed it in first, right? And that's not what we want. We don't want -1 times 3 squared. We just want -3 squared, right? So what you should do when you type it in is either do it the old-fashioned way, which is -3 times itself, because that's what -3 squared is. Just do it the old-fashioned way. We're multiplying -3 twice, right? You get +9, or you type -3 altogether in parentheses. You see, that's how I wrote it down on my paper. -3 in the parentheses and square it. Then the calculator registers it properly, gives you the +9, okay? So just be aware, avoid the mistake of typing this in wrong to get a -9, because a -9 is not the same as a +9. And if we did that, if we make that mistake, then the rest of the problem is going to be wrong. So let's avoid making that mistake. But you can see, like I said, I wrote it down with the -3 in parentheses. So let's put all this together right now. We're going to have, let's go ahead and work that one out, right? Negative, that's going to turn into a +3. So let's just go ahead and take care of that. So we have a 9 here. Now the next thing I'm going to do is this. Now, keep in mind we have a -4 times 1 times -4. So if we actually include that negative in our calculation, right? So if I actually use that minus sign in the calculation as a negative, so -4 times 1 times -4. So you can see I'm typing it in exactly the way it's written in the formula, but I'm using that minus sign that's right here, and I'm typing it in as a negative in the calculator, right? That's going to help me out, because what it's going to do is give me an answer. Now, based on my answers, we'll focus on the sign that I write. Now, I have a 16 here. And since it's a +16 as a final answer rather than a -16, I'm going to go ahead and write my answer as a +16. So going back to the previous problem, just to make sure I don't confuse you from that one, right? I kind of circled it badly. I should have circled it like this, because the way you could type it in, including the minus sign that's there, right? The way you would work that one out, it would have been a -4 times 1 times 1, right? And the answer is a -4. So since that number was a negative, that's the reason that minus sign is there, to indicate the -4. But since my final answer here, when I typed all these values in, was a +16, that's the reason why it's a plus now, okay? So the answer will dictate what sign you're going to put there. So if it's a positive, put plus. If it's a negative, put minus. All right, all divided by 2 times a. Now 2 times 1 is going to end up making 2. So there are 4 parts I've already simplified kind of in one step. And that's usually kind of a lot, but, I think we'll be okay. All right, so the next step, let's focus still inside the radical. So 9 plus 16. 9 plus 16 is 25, so we're going to have square root of 25 divided by the 2 still. All right, so again, we're still focused inside the radical. The square root of 25. Well, this one is a perfect square. Square root of 25 is 5. So this is going to become 3 plus minus 5 over 2. And now the radical's gone. Keep in mind, when you do the square root, okay, you've taken the square root. You remember, it's called taking the square root for a reason. You took it, right? It's gone. It's not there anymore. The square root part is gone. It's just a regular number now, okay? So keep that in mind. That's why that radical sign goes away. But now, since the radical sign's gone, we have two equations to solve, one with the plus, one with the minus. So let's do the plus first. So we're going to focus on 3 plus 5 over 2, and then we'll focus on the minus sign, 3 minus 5 over 2. Okay, so let's just work out both of these. So 3 plus 5 will be 8. So that'll be 8 over 2, which ends up being 4. So we have one answer. And then the bottom part, 3 minus 5 ends up to be negative 2 over 2 still, and that ends up being negative 1. So our two x-intercepts would be at 4 and negative 1, or the two answers, the two roots, at 4 and negative 1. So there's that example for you. So yes, it's kind of a process, but it's a simple process. It's one that's easy to follow. It can take some time if you're careful. If you rush through it, chances are you'll do something wrong, so just be very careful. All right, let's look at this one, because this one's kind of written funny, right? So we have negative 3x squared minus 9 equals 5x. So we have negative 3x squared minus 9 equals negative 5x. Let me double check that. Yeah. All right, so here's the problem, right? In order to use our quadratic formula, we have to use a quadratic that's written in 0 equals a x squared plus bx plus c, right? The only way we can use a quadratic formula is if we have quadratic written in this form, because then we can determine what the a, b, and the c are. Now, since this is not written in that form, I can't really tell you what the a, b, and the c are, because we have to have, all three of these terms be together on the same side of the equal sign, and have it all equal 0. So when we see something like this, the first thing we should try and do is try to put all three terms on the same side. So since the negative 5x is kind of out here, right, away from the others, let's try to move that one back over to this side. So since it's a minus 5x, a negative 5x, we're going to simply move it by adding 5x. That's going to be able to cancel it out, and we can throw it over there. Now, the 5x does not combine with the 3x squared or the 9, because it's not one of those terms. It's a different term. It's not like terms with any of those other two. So we're going to just write it mixed into those. And we're going to write it, remember, in this format. So if we keep it in this format, then the negative 3x squared will be first. The 5x, which will be essentially our bx here, will be second. But since remember, it's a plus, so it's going to be plus 5x. And then the minus 9 will come last, so that we have all three of those terms written in the same order as a quadratic should be written in. And then this is all going to be equal to 0, so now we can go use the quadratic formula. Before I use the quadratic formula, let me go ahead and write out this color-coded. So we have negative 3x squared plus 5x, 5x, and then minus 9. So again, you can see that a is negative 3, the b is 5, and the c is negative 9. So you guys know the formula by now. I'm not going to write it, but I'll just go ahead and plug everything in. So the formula is x equals negative b plus minus the square root of b squared minus 4 times a, which is negative 3, times c, which is negative 9, all divided by 2 times a. So we have quite a bit of work ahead of us here with these numbers. It's all the same thing. We just have to calculate it all, remember. So let's do this. So first thing I like to do is focus inside the radical again. So 5 squared. So 5 squared is going to be 25. So let's change that. So this is still going to be negative 5 plus minus. The 5 squared is going to become 25. So that's what we did first. Let's do this second. Remember to keep that negative included, okay? So the minus 4, keep it included as a negative. So let's go to the calculator and type this all out. So the minus 4 or negative 4. And make sure, by the way, that you're typing in the negative here, not the minus sign here, because those do register differently, okay? So the negative, not the minus sign. So negative 4. So if you get an error, it's probably because you hit the minus sign instead of the negative sign. So be careful about that. Times negative 3, and then times negative 9. So this is going to get us negative 108. So since it's a negative number, that means I'm going to be typing in a minus 108. Okay, so a minus sign rather than a plus since it was negative. All divided by 2 times a. So on the bottom we have 2 times negative 3. That's going to become negative 6. So we've simplified a lot of pieces here. Let's continue. So let's focus again inside the radicals. 25 minus 108. Let's use our calculator. 25 minus 108. We end up with negative 83. So, okay, so this is going to be negative 5 plus minus square root of negative 83 divided by negative 6. So we just simplified the 25 minus 108. Now we have to do the square root of negative 83. All right, so let's go to our calculator, type in square root of negative 83, and we get, oh no, something went wrong, right? We have an error, non-real answers. Okay, so here's what's happening. And you'll learn more how to do this in Algebra 2, but for now, being in Algebra 1, let's explain what this means. I can't take the square root of a negative number. If I ever try to take a square root of a negative number, I'm always going to get an error because this is impossible. This doesn't work. There is no number like that. Because essentially, remember what you're asking is when you take a square root of something, you're asking, hey, what number would I square that would equal that one? So in the previous problem, remember we had 25 there. So we were saying, hey, what number do I square to equal 25? And we know that number is 5, so the square root of 25 is 5. But in this case, I'm asking what number times itself equals negative 83? And this is impossible, not because it's 83, but because it's negative. Because if you square a number, that means you're taking some number and multiplying it by itself. So if that number was positive, a positive number times a positive number would equal a positive number still. If that number was a negative number, then a negative number times itself, so a negative number times another negative number, a negative times a negative would still become a positive number. So no matter if the number here was a negative or if this number was a positive, anytime you multiply it by itself, it would still be a positive number because a negative times a negative would be positive. A positive number times a positive number would still be positive. So every time this number should be positive. So it's impossible for this number to be negative because of that. So you can't take the square root of negative numbers because there's no such thing as a number that can be multiplied by itself and then be negative. Because if the number was positive, like I said, a positive times a positive would end as a positive. A negative times a negative would still end as a positive. So there's no way you can get that negative. So that's why it gives you an error. So what this means is when this happens, we're kind of, in a way, sort of ending the problem here. And what this means for us is that we have no x-intercepts. There's no way we can calculate the rest of this problem, which must mean there's no x-intercepts. So on a graph, here's what the graph of something like that could look like. Your graph might look like this. So you see in the x-axis, y-axis, the parabola doesn't hit the x-axis. It goes up and then comes back down before it could ever hit the x-axis. So that's why it doesn't have any x-intercepts. This is possible. Most of the time, it goes up and over like this, which is why we see two answers, right? Which is why we got two answers on the other examples. But in this case, if you were to try and graph this function, you will see it won't hit the x-axis. And I can prove that because I do have a graphing calculator, right? Let's clear this. Y equals, what was our quadratic? We had negative 3 x squared. Let's just clear that. Let's just delete all of that. Here we go. All right. Negative 3x squared plus 5x minus 9. This was the quadratic we were trying to work out. If I go to graph, we'll see it won't hit the x-axis. So there at the bottom, you can see, like I said, it went up, but then it turned around. It never hit the x-axis. So it doesn't have any x-intercepts, which is why we end up with the error in the problem. There's nothing wrong. We didn't do anything wrong. That's just how it rolls sometimes. But that's the answer we get. All right. I think you guys get the point of the video. Let's see if there's anything more to work on. Okay, so yeah, just real quick, something called it says radicand. I'm trying to remember the name that it gives it, but anyway, we can actually tell how many solutions something has. This is a little chart to help you remember, but the quadratic formula. Let me write it down again, but I'm not going to color code it this time. Negative b plus minus square root of b squared minus 4ac all divided by 2a. The quadratic formula. Focus your attention on this part. Okay? So if we just focus on that, right, the b squared minus 4ac, if you just wanted to calculate this part, which is kind of what we do every time, right? We're always calculating that part first. We're always trying to evaluate that part. Back in this problem, we did all of this stuff first, right? So, but if you just take it in its own sense, if this number ends up being a positive number, then you're always going to have two solutions for the quadratic. If it ends up being a negative number, then you're going to have 0 solutions for the quadratic, just like we had in the last one, because the last problem ended up being a negative 83. So a negative number means you'll have 0 solutions, no x-intercepts, because like I said, you can't take the square root of a negative. If the number there ends up being exactly 0, so if you end up essentially having inside here the square root of 0, then your quadratic is going to have just one solution, just one answer, rather than 2 or 0. So just something to keep in mind, and I think that's kind of what the chart here is telling you. You see it says number of solutions 1, 2, 2, and 2. All right, well actually, let's see, which one is it? The last one, the one at the bottom. The bottom row. You see it still says 2 solutions, but here's the thing. Look to the right, it says no real number solution. And again, you can see on the picture that it doesn't hit the x-axis. Now, it does have 2 solutions, but they're technically called imaginary solutions, and that's not something we're going to get to in Algebra 1. You're going to learn more about imaginary solutions in Algebra 2. So it has 0 real solutions, no real number solution, but it does have 2 imaginary solutions. So if you're confused why it says 2 there, that's because it's talking about something that you really don't learn until Algebra 2. Now, just to make things easy for you guys, if you have quadratics like this, okay, so you have ax squared minus c. So let me look at this example, 4x squared minus 7, right? So 4x squared minus 7 equals 0. Now, you'll notice that this quadratic, 4x squared minus 7 equals 0, we're kind of missing the bx term, right? That term is not there. And that's fine. If you're missing a term like that, you don't have to use a quadratic formula. If you have a quadratic like this where you're missing the b term, okay, so no b term, right? Just solve it the old-fashioned way. It's pretty simple. We can just try to solve for x. So you would add 7 to cancel out the 7, move it over. This will leave you 4x squared equal to 7. Then you can divide by 4. This doesn't work out nicely. It's a fraction, but it's okay. So divide by 4. We're left with x squared equals 7 over 4. I wonder, did they use a decimal version in here? They didn't use a decimal, but I'll go ahead and make a decimal for you. Or we can leave it as a fraction since they leave it as a fraction. I'll try to make sure you guys understand exactly what they have written. So we're going to have x squared equals 7 over 4. And then they take the square root because it's the opposite of squaring something. So the square root of x squared is just going to be x, but now we have to do the square root of 7 over 4. And what they're doing is square rooting each part. So square root of 7 and the square root of 4. This simplifies into the square root of 7 because there is no square root of 7. It would be a decimal. But the square root of 4 is 2, which is why the bottom part doesn't have the radical anymore. So if you look at the answer here, the bottom part doesn't have the radical anymore because the square root of 4 turns into just a plain old 2. But they do have the plus and minus. Don't forget about that. Anytime you take the square root of something, you end up with the plus minus, which is why in the quadratic formula, the plus minus is in the formula. The plus minus is in the formula because it knows this step happens throughout the process. So when you take the square root, you get plus minus. So that's why our final answer here is x equals plus minus square root of 7 over 2. But yeah, you could have gotten a decimal from that. So you could just simply type in, you could have done your calculator. Let's go back. You could have just done your calculator 7 divided by 4, right? And then you could have just taken the square root of that. So the square root of 1.75, right? So that's a decimal version of our answer, positive and negative version of that 1.32. And let me just type it in the way we have it as well, so you can see. So square root of 7, arrow out of the square root, divide by 2. It's still going to be the same number, right? So it's still simplified in the same thing, but it's still the same decimal version of it, right? All right. If you're missing the other part, let's say you're missing the c term. So look at this one, right? ax squared plus bx equals 0. So this example, they have 4x squared plus 8x equals 0. So 4x squared plus 8x equals 0. So we got the 4x squared plus 8x equals 0. So in this case, you'll notice that they're missing the c value. Okay, so if you're missing the c value, again, you don't need to use the quadratic formula. Here's a better way of solving it. If you're missing the c value, then these two terms have a GCF, in which case you can actually solve this through factoring. Factoring would be a lot faster. So if those two terms have a GCF, you'll notice that GCF, let's actually rewrite the problem down here. We're going to have, let's rewrite as 4x squared plus 8x equals 0. Right? These two terms, because there is no c value, both terms, let's just factor by GCF. Both terms can be divided by 4x, right? Because both terms can be divided by 4. Both terms have an x in it. So we're going to factor that out, 4x, and we'll end up with x plus 2. And so now all we have to do is set each part equal to 0. So 4x equal to 0 to solve it, and x plus 2 equal to 0 and solve it. So first one's pretty simple because you divide by 4, and 0 divided by 4 is still going to be 0. And then the next one you just subtract 2. So x equals negative 2. So that took a lot less time than having to go through the whole quadratic formula. So if you're missing the b value or missing the c value, just remember there are simpler ways of solving problems, Sometimes they take a lot less time, a lot less work to figure out. So missing the b value, no problem. Okay, just work it out like it's an equation. If you're missing the c value, no problem. Just factor out GCF. Okay. So it makes it pretty easy in the long run. Okay, I think I'm going to let you guys practice a little bit. Good luck with it. If you have questions, remember you can ask us. We're here to help you with anything you need. I'll see you in the next chapter. All right.